for
Recording in progress.
okay. So best practices for design and installation of solar PV systems. That's what we'll be looking at today. And our facilitator for today is our lead project and technical engineer Kunle Olorinkoya. He'll be the one taking us on this topic. So I promise it's going to be a very insightful, informative, and interactive session. Please mute your mics so that we don't have holdbacks. Interactive sessions, and we'll also have the Q&A at the end of the presentation. So if you have any questions, you can start dropping them in the chat box, and we'll also give time for people to speak up and ask their questions. So just a little or brief introduction about Gennex Technologies. Most of us already know, of course, that Gennex is the leading solar energy company in Nigeria, a renewable energy company in Nigeria, and we're into the sales and distributions of solar products. So we distribute a range of solar products from inverters, different brands of inverters. We have our Gennex inverters. We also have Growat inverters in different capacities, in different models and capacities. So we also have batteries as well, which is a major component of solar systems. So we have lithium batteries, and we also have the lead acid batteries. We also have the solar panels from our major, we are major distributors of the Canadian panels, solar panels, and also the Jinko solar panels. So we have all these products available in stock. So you can also always visit our website or walk into our office at Ikate. Once you go to our address, you see our website at Ikate Lekki to find out more about this product. So we also have our rechargeable fans, lighting, rechargeable fans. We also have LED lighting and various products that you can pick up from our store. So Gennex is also into the installation of residential and C&I solar solutions. So we've done a number of projects across Nigeria, and both residential and also the C&I, different capacities of solutions. And we also run a solar academy. We have one currently ongoing. So a solar academy where we train, individuals on how to become professional solar installers, and, how to design solutions, how to install systems, and how to do, all the information that they basically need, to do their work in the industry, to launch into the industry. And we also offer support for them even while they've launched into the industry. So our next training will be coming up sometime in August. We'll keep you informed. So, but you can always go to our website to register so that once we are starting, we'll reach out to you to give you the necessary information. So right about now, our facilitator will be coming up to taking us on the different on our topic again, which is best practices for design and installation of solar PV systems. So they'll be taking on from now. Thank you. Kunle, let's have you, please, sir.
Good morning, everybody. Kunle is my name. As mentioned, I think we have to start right about now. You're all welcome. Okay, we are going to talk about design of solar PV system. So to achieve this correctly, I think step by step, we have site evaluation where you need to check the loads and energy requirements of the client. You inspect the roof conditions and available space and the orientation. Where is it facing? Is it facing north? Is it facing south, west? You know, all these are necessary. Then you analyze the shading and the obstructions on the sites, because that's the reason why site assessment is very important. While you are there, you see what could be an hindrance to the power you want to generate. So you look at that and consider them in your design. You analyze shading and any obstruction. You check inverter and battery location, because the clients may have programmed that the inverter should be in a location, and professionally you just gather every information that is required. So professionally you'll be able to suggest better place, you know. Then you check for electrical infrastructure. If they need to put some things in place for you before the installation commences, then you raise it. You take notes of everything. Don't forget, we are talking about the best practices to achieve a good solar system installation. So next on the slide is inverter sizing. So where you need to do a load calculation, at least you need to have an idea of what the person wants to power, because that is going to give you the size of the inverter that you are going to use. You are going to consider the type of load too. Do they have three-phase load? Is it inductive load? You know, so these two will affect the type of inverter you are going to put there. So it's going to help to determine the type of inverter that will be there. Then you consider the model of inverter itself. Is it high voltage? That's the high PV input. And this, from the roof pattern, you know whether you need a high PV input model inverter, or just the one you just connect the solar panels in 2222, which is low voltage, maybe about 100 and something, or maybe 150 volt or thereabout. It means all the panels will be in a system, does not have a platform that can take that. Then you know you have to change the inverter from high voltage to a low voltage type. This is important. Next one is the sizing of solar array. You know, size slash specifications of the solar panels. It's very important to know what type of panels you want to use. The specifications matter. We have different types of panels with these days now we have high voltage panels. Before you could see just a single panel with maybe 35 volts, but now we have 50 volts, we have even higher voltages. So you consider that too. And then in connection with the inverter you want to use and everything, and your roof too. Because if it's going to be two panels in series, and then the voltage is even higher than the MPPT you want to use, you know, that's no-go area. So all these considerations have to be put in place. Number of solar panels to be used, because you know, is the number of solar panels that you are using that will determine the capacity of energy you are getting from the roof or from the roof space. So the but here now, you have to consider that, okay, if you want to use this capacity of solar panels, you should consider the inverter that will also accommodate it. All these are interwoven. So angle of the sun also matters, because if the panels are facing wrong direction, you won't generate enough energy, and then it will impact badly. That's that. Then it required a backup time. You know, the battery bank is like a tank. So as a result, you have to understand that this person wants to use the solar system in the night, unless the client says no, it's not doing that. There are batteryless systems that are working out. So battery bank requires that the size of load that will run on it for a particular period of time will determine what the battery size will be. So specifications of the inverter at that time, when you are sizing battery, is also important. You should not size a battery bank that the inverter cannot charge, because the inverter can always use any energy stored in the battery, yes. But the type of battery you are going to use, you should not use like for instance, you have a 48 volts battery and then you have a 24 volts inverter. They don't match. So all these considerations are very important. Power requirement as regards battery bank sizing. You should know what's the total power that the person wants to take from the battery, because battery have specifications. There is a limit to maximum current you can deliver, you can take from the battery, so that you don't kill the battery for its time or within a short time. So I think that's very important to consider. The next one is other design consideration, like sizing of cables. Improper sizing of cables can lead to many things. It could lead to fire, it can burn the house, it could lead to very important to size protective devices. Also, very install a system and you won't have rest of mind. We're calling you here and there, come today, come tomorrow. If everything is done properly, it does not require maintenance so frequently. The system will just be running. You have upgrades that run, and they run for years without anything, but maintenance plan will always be there. But it's not that you did installation like a week and then your customer did not allow you to rest. So all these considerations are very important, like your breakers, your power limiters, surge protectors, lightning arrestors, all these components. They are external components that protect your solution, protect the inverter, protect the batteries, protect all those key components that made up the system. So it's very important to make sure that they are in place. They come at a cost, of course. Thank you. So installation of solar PV system. Now, you know, we mentioned things to be considered on site. Yeah. So it's not good to install a system where shadow would disturb it, and then you will have put panels in place, and then you are expected to generate a certain amount of energy, and what you are getting is low, because that's the implication of shadow on solar panels. And then it will now be like a wasted effort, waste of money, you know. So any effect from shadow, please, is worth running away from. Then it's not a good practice to stand on solar panels. You can see a picture of where somebody is standing on solar panels in the middle of the panel. Safety is key. When you are doing this, you should be safe, be safety conscious. Safety to humanity and safety to all the components that are there. If you don't take care of your tools, for instance, you won't get their advantage. So if you don't protect the solar panels, they will get damaged on site. And we all know what the cost of all these things are saying now. Things are expensive, and then this is a rooftop engagement, and one has to be very careful. So safety is key, I repeat. So panels, movement on the roof has to be professionally handled. So that's about the panels and effect of environment and situations around it. So installation of solar panels, like we've seen in the picture, perform is according to the system design. Because you've gone to the site, you've carry out survey, you've done all this, then you should do your installation according to this specifications, design spec. You can't design tools. If you don't have proper tools, it's dangerous, and then it waste your time, waste money. The outcome of the whole installation may not be fine. So you need to get put in place the proper tools for a proper installation. Then mounting of PV modules. We have different materials that people use in mounting modules on the roof. One has to be careful. This is roof top installation. Whether it's a shed, whether it's on the ground or anything, at least you have to, even if it's a rack that you are going to put on the ground, it requires a proper installation. So you should use appropriate material, like normal standard racks, not racks that when wind blows and then to just remove them from the roof. Some people will do installation, they'll just put one screw to hold panels, and this has to be, if you want rest of mind, you have to do everything professionally. So mounting PV modules professionally is very important. Choosing the right location of the system for the system, it's important. Right location for solar panels, right location for inverter, right location for batteries. So it's very important. You are not expected to put, for instance, an inverter in the bathroom. Keep them in well ventilated environment, and then solar panels, like we mentioned and emphasized on, that they are to be exposed to sunlight, sun rays, so that they can capture energy. If shadow is on them, it's a problem. So the right location, the right direction for solar panels is very important. Then installation and connecting the system components. This is also very, very important. I mentioned using proper tools that time. If you don't have proper tools, you may be connecting the system in such a way that there will be a problem at the end of the day. Because where you are supposed to tighten a screw properly, because you don't have proper tool, you do it partially. If there is partial contact where heavy current will flow, it could lead to burn, arcing, fire, cables can burn, breakers can get damaged, inverter can get damaged, battery terminals can get corroded. So many things can happen. You can see the advantage and importance of proper installation and connection of all these components. So ensure proper earthing. It's important. It's also a safety device, because if your system is earthed, even if there is a link of life to the body, earthing is expected to take it down. So, and then, or a breaker will trip or something will happen, which will call attention that, oh, this is what. But if there's no earthing and life touches the body of the inverter, it can electrocute anybody. So please, it's very important to ensure that a proper earthing is done. Then before commissioning, make sure you test all the components that are put together. Check, double check, visual inspection, test with meter, make sure that everything is done professionally. Then you can now go ahead through the commissioning process or procedure. Thank you.
Okay, thank you so much, Engineer Kunle, for that insightful session. So a very quick one, but a very insightful session. So I'm sure that some of us may be familiar with some of these things, but emphasizing them again and again and again, it's very important, because you can't afford to cut corners, and we can't do bad work, if I put it that way. So we have a lot of people in the, today, end users today, who have a bad impression about solar systems. So we are always key on emphasizing the best practices to design your system, because that's the starting point. Designing this, designing your systems, and how to also install them. Less stress. You have less calls from your customers disturbing you that, oh, my system is not working, something is happening, and then you're getting referrals because your installations are done properly and your clients are also happy. So that's why we keep emphasizing these things, because we want to grow the market and also ensure that we have good value for whatever we are doing in the industry. So we'll be taking questions right away now. So I don't know if anyone has any questions in the chat. There's no question yet. So if you would like to speak up, okay, I can see a hand up. Mr. Dekunle, you can go ahead, please. Please unmute.
Okay, good morning.
Good morning, sir. Please go ahead.
So I really appreciate the emphasis in that areas of installation. But I missed something else when I've been talking about the battery. It make mention of specification of batteries, the number of solar panels that will match the battery to be charged fully. So I want to recall other tools that I've mentioned regarding batteries. Is that what?
Hello, sir. We can't seem to hear you clearly. Please, can you take that
Okay,
again?
okay. I really appreciate the consideration, sir. When you're talking about the battery sizing as of, I want you make a mention of specification of the batteries. Hello?
Hello, can you hear me?
I'm
Okay. I need to get that question right. Specifications of batteries.
okay.
I don't. I need to get what you want to.
You give me you highlighted some points regarding the sizing of the batteries. So I note two. I know two. What I want to add the other two. That's what I'm asking. You make mention of specification of batteries and the number of solar panels that will require to charge the battery to a fullest level. I want to add the two. That's what I'm asking.
You want to add two additional.
One of the points that you make regarding the battery sizing.
Okay, you can go ahead.
I missed two out of the points. That's what I'm saying. Out of the points
Okay.
listed. Yes.
Okay, the listed points that time you
Points. Yes.
missed some.
Yes.
Oh, okay.
Yes.
That is the battery bank sizing, right? The
Okay.
first
Battery bank.
one is required backup time, because that's what is going to determine the size of the battery at the end of the day. Then the specification of inverter. You know, that's why I mentioned that your inverter that you want to use to manage the battery must be capable to manage that battery. And then the specification must conform, not you having 48 volts battery and then you have 24 volts inverter or something like that. Then the capacity must match. Then in terms of the number of solar
Okay.
panels, depending
Solar
on
panels.
the assessment and everything and agreement with
Batteries.
the client, if it's just the one that will just charge batteries for for usage in the night, you know that your solar panels is will just be sized for the one that will charge batteries. But if they want to use it at the same time, you will make
And the night.
provision for the one that will charge batteries and power the loads during the day. So number of solar panels, and your inverter must be able to do that. So that's the sizing the batteries as well. Then power requirements, the power that you want to get from the battery, will also determine what the size of the battery will be. If the power is more than the battery, then the battery will quickly die.
Exactly. Okay, sir. Thanks, sir. All right.
Okay, sir. Thank you so much, Engineer Kinley, for that clarification. So I also see a hand here, Mr. Sahid Opemi. You can go ahead and ask your question, sir. Mr. Sahid, can we have you, please? Are you there? I see your hand up.
Hello, can you hear me now? Hello, can you hear me now?
I can hear you.
Okay, thank you very much, Mr. Adekunle or something, and the moderator also. Thank you very much. My question is still on the two areas. On that issue of the battery that you are saying, when the power that is powering the voltage of the panel is higher than the battery. If it is the otherwise, when the power of the panel is lower to the voltage of the battery, is there any effect on that one? That is one. The second is that the issue of training that you made mention, you say it is usually coming up by August this year. Must it be August, or you have other classes that you do take irrespective of the time? That's my two questions.
Okay. Thank you for your question. The first one, we are talking about the power being low or high, how it will affect the batteries. Yeah. If it is high, if the power is too high, the demand from the battery, it will damage it. But if it is lower and you charge the battery properly and everything is, the only thing that will happen is that you will have a longer backup time. Instead of the battery to drain quickly because you have high power from it, then the battery will work for over a long period. That's why you hear some people, maybe they have a battery that's supposed to power maybe 1,000 watt load for 10 hours. They just put maybe 200 watts on it. They will now tell you that it's 24/7. That's kind of a language that is 24/7 because the load on it cannot really drain that battery to empty when they have solar panel on it. So if you have a smaller load on your battery, then it's going to last longer, provided you have an inverter that to manage it well for you, charging it properly to full, going to float, all those functions. Then you don't have any problem. It's only the high power on it that will quickly kill the battery in most cases. So that's that. On the academy, the only training that we have is something like this in between for people or a programmed occasion, not the academy. Academy is just like a school. Then it runs within a period of time and then it's fixed, is section by session. So that one is fixed. The session is running, almost finishing. Another one will start that time. 2 sessions in a year, and then that's that. But other programs that will be coming in between is something like this, either on internet or in a location, event center, like that. And when such program is coming up, you will always be notified, carried along. Hope that answers your question.
Yes. So you mean the next training now, it will be during the August. And how long is the duration of the program? I mean the training.
I think that's okay.
I can't hear I can't hear your reply.
I said the next training will be in August.
Duration.
Another one will start by that time. Location.
I said duration. How long it will last?
12 weeks, only Saturdays.
Okay. Noted.
All right.
Thanks.
You're welcome.
Yes.
Okay, so any other questions, please? We still have some minutes, about 10 minutes to still take questions. So you can drop your questions. Okay, I can see a question here from TK. Let's hybrid inverter. Same time, no battery will be connected because the inverter would only be used during the day. So I'll take that again. In terms of batteryless hybrid inverter, can I parallel it and at the same time no battery will be connected because the inverter day. All right, so Engineer Later, please take that.
Okay. In terms of the batteryless system, you want to know if you can parallel and install without battery because the system will function during the day. Yeah. You You cannot parallel the system without batteries, depending on the manufacturer. So specification of the system is very important. You need to find out if the manufacturer says